olfaction like it is in a dog and a lot of higher forms of mammal. It's the strongest and the most reliable sense that they have. We'll tell you why in just a minute, but if you've been to deer hunting, you will know once in a while you can get by with a little movement. Once in a while you can get by with a little noise. But if they smell you, you're all done. They trust that implicitly, and that's the bottom line. Same with a dog. But deer, elk, all of the cervids are like that. The reason that that is so important to them is because of the neuroscience involved. The signal coming from those olfactory sensory neurons is on what we call a flat track to the brain. It only goes through one synapse, whereas a normal neuron, other sensory neurons, will go through a synapse, through another synapse, through another synapse, through another before they get to the brain. Up to hundreds of them. These go through one. So that signal of whatever they have smelled gets to the brain the quickest of any sensory signal. That gives it priority. That's why if they see something move, I'm not so sure, but if they smell it, you're done right now. Boom. So that's what's going on with that. And it's a neuroscience thing, but that's the bottom line. That's why it is so important to them and to us. The other things that we do know that have been researched on the whitetails, their olfactory system is very similar to other higher forms of mammals and other large ungulates. It's a bilateral system separated by a septum, which means there's two olfactory systems, one for each nostril. Reason being twofold. One is for directional. If you're getting more molecules that you're looking for over here, that tells you they're coming from the left. The other reason is damage control. If something has injured that deer and wiped out this side, he's still got a very viable olfactory system available to him. They are different from, say, omnivores and carnivores in that the ethmoturbinates, which are at the end of the system, that's where most of the scent sampling happens. On a deer, they're very convoluted and folded. This increases their surface area, which is actually a good thing. Mm-hmm. But in a carnivore, it's a scroll-like deal, which enables them to process scent a little bit faster because they're hunting stuff. Deer, as I said today, they don't need to hunt down that soybean. It's not going anyplace. So they can afford a little time lapse, and I'm talking milliseconds, over a carnivore. And that will get the scent into those ethmoturbinates where it is sampled. Now, the other part of the olfactory system is respiratory, okay, basic breathing. That complex in a deer is a little less complex, as it were, than it is in a carnivore. Also for the same reason. They don't have to hunt their food down. It's not going to make a big difference in the time given to process scents, but it just makes things easier for the deer.
Quick question: when you're talking about like in a cervid, a deer specifically, compare like a carnivore, say we're going to use a dog or even maybe a bear. The cervids, the deer's specific nasal structure, you said is less complex of a design.
Right.
Does that affect at all when it comes to scenting capabilities, or like what other than the speed of their smelling something, which is just the difference of milliseconds?
It does affect it, and it gets a little complicated. It doesn't affect it in a negative way. I'll put it that way.
Okay.
It is less complex for a number of reasons, but what happens when it's less complex with deer? We're about to get geeked out here. when they go into a sniff mode, all of the air that's going through that system is suddenly what we call a turbulent flow, which has the molecules bouncing all over the place, which helps in their convoluted ethmoturbonates, but it doesn't help in the interim. It makes it a little bit harder. Whereas in a carnivore, the stuff that is actually going to be sampled by the ethmoturbonates is slowed down to a laminar flow, if you know your fluid dynamics. So that's a little different in that regard. Let's see what else we got. Okay. We talked a little bit about the OSNs, the olfactory sensory neurons. Basic dog, this is conservative, but a basic full-size dog has 220 million olfactory sensory neurons, up to, they claim, 300 million. Now, the deer, judging by the surface area of the ethmoturbonates where things are sampled, will be closer to the upper end of that. They'll be closer to 300 million because they have a very large surface area to sample with. The respiration rate, basic breathing, is very much like a dog or like a human. It's 1/3 to 1/2 of a breath every second. It's 0.3 to 0.5 hertz. That's another fluid dynamics thing. Now, when they go into a sniff rate, when they think they've detected something, and they go into a sniff like a dog, like I said, if you've been around any dog, you know just what I'm talking about when I say rapid sniff. Because all of a sudden they go from to. Deer will do the same thing, and they're basically at the same rate, at 10 times their normal rate of breathing. So it's 3 to 5 times per second instead of 0.3 to 0.5 times. What that does is twofold. Obviously, it brings in more air to sample. We don't know this with the deer, but how much of that air is actually getting sampled. When they're just plain breathing, we don't know how much of that gets sampled, but when they go into a sniff mode, more of that air is being sampled, and they're taking in 10 times as much. So all of a sudden, the olfactory capabilities go exponential, okay? So when they think they've noticed an odor that they want to check out, that's how they check it out. And again, it gets to the brain the fastest. So it lets them know that they're in trouble or not. We have to guess at this again because it hasn't been quantified, but everybody wants to know how much better can they smell than a human. If you go just by the number of OSNs and by their breathing rate, it would be 600 times better. And that would be a very conservative estimate. When they go into the sniff rate, again, like I said, things go exponential. We don't know how much farther than that, but they just blow up completely. So the one other thing, and deer hunters already know this, the deer do have a vomeronasal organ, also known as Jacobson's organ, on the roof of their mouth, which responsible for detecting pheromones. Mm-hmm. That's why they do the Fleming thing. That's why they lick the air during the rut. They're sampling that. The tongue goes back in, places those molecules on the Jacobson's organ, and it verifies there's pheromones or there's not.
But Andrew, as you're now just hearing this,
Yep.
what is your take on some of that specifically? We're talking about like the rapid sniffing, potentially we don't know exactly how much more they can smell, but exponentially more capabilities. And also, specifically, you think about this as a whitetail hunter dealing with all the environmental factors we deal with, the weather conditions, thermals, wind. What's your thought process now getting into this conversation?
Like when you say that it's 600 times better than our smell, it's surprising, but not really. Right? Like we know that they have a much better smell. So it's almost like if you said it was 1,200 times better, I'd be like, yeah, that sounds about right.
Yeah.
You know what I'm saying?
Well, 600 is a wild guess on a radically conservative side.
Yeah.
I mean, that's that's the least. So yeah, we don't know. It could be 1,200 resting, but we do know it increases exponentially when they go into sniff mode.
And this maybe ties into the analogy that we've heard a bunch of times, where you walk into the house and you smell a cake, but the deer walks into the house and he smells the flour and the eggs and the butter and the.
Yeah, not so sure about that, but there is some merit to it, because we touched on kinetic molecular theory. Bonding takes place at the atomic level, not on the molecular level. So yeah, they would smell each individual scent. It's like dogs and, the drug dogs and coffee. What they smell is the scent of coffee and the smell of drugs. One does not hide the other. So yeah, in fact, in the old days in canine, the same exercise was used. You go into McDonald's, you can smell them cooking up a Big Mac. The dog smells 2 toasted sesame buns, pickles, lettuce, mayo, smells everything. And that, like I said, there's some merit to that. The deer would be no different.
Another analogy I heard today at the expo, talking to our buddy Jacob. Jacob, I still don't know how to say your last name. Sorry, bro. He was saying that a good way to look at it is our eyes are better than a deer's eyes as far as like perceiving color and stuff. So if I'm looking at that painting on the wall right there, I can see that there's kind of a little bit of orange on it. There's a little bit of blue. There's blacks, grays, and it's me perceiving that is instant and effortless. And
right. It's
the same way for a canine or a deer with scent. When they walk in, that the things that they smell, they don't have to reason about it. It's like me looking at a picture. It's instant and effortless.
Yeah, because to us, our eyes are our most important sense. And if you look at it and dissect it, you have 250,000 photons in your eyes. Or I'm sorry, 250 million total. That's a sensory neuron. They have 250 million in their nose. That's important. You have 5 million. So yeah, this is most important to us. The nose is most important to them. And again, you'll trust your eyes, right?
Yeah.
They don't always, unless it's a glaring example. But like I said, you can get away with a little movement. With us, you can't get away with a little movement, because that's what we rely on.
Yeah, interesting. Yes, that's you like that example?
That was really good.
I didn't come up with it. I told Jacob I was stealing it from him.
That's Jacob S. I can't say his last name.
Sklinner, I think. Man, I'm sorry if I pronounce it. I don't know. I think it's Sklinner.